everyone. My name is Nidhi. I am assistant professor in Suresh Gyan Vihar School of Pharmacy. That is a part of the Suresh Gyan Vihar Untitled Chapter. Today we are going to discuss this topic, that is one classification and nomenclature, and it comes in the pharmaceutical organic history first. So let's discuss this topic. So the learning objective of this topic is that we are going to learn about the nomenclature of organic compound, but what is the nomenclature of organic compound and how we nomenclate the organic compound. And also we are going to study about the nomenclature of other molecules containing substituent and functional group. Means here we are going to nomenclate, we are going to discuss about the naming of organic compounds, and also we are going to discuss about the naming of organic compound, having different function groups and having the substituent also. Because in the last lecture we have already discussed about the primary sequence. So here we are going to discuss about the nomenclature of this nomenclature of molecules that are containing the substituent and the function group. And the student outcome is that we are going to know about the nomenclature of organic compound, means the naming of organic compound, and they will also learn about the nomenclature of other molecules containing substituent and function group. Means they are going to learn about that how we are going to give the IUPAC nomenclature to the molecules that are containing the substituent and the function group. So here we are going to discuss all about these things. So today we are going to discuss the topic, that is the introduction. So the introduction is that the purpose of this IUPAC system, that it is made, this IUPAC system is made for to develop an international standard of naming compound to facilitate communication. Means here they have given this IUPAC system of a nomenclature of naming is to establish an international standard of naming compounds to facilitate your communication. Means in all part of the world, if we are giving a molecule a name, that should be the same name, not the different. That in the different country, it is naming the different compound, and in this country, we are naming it different. So they have given one system, that is your IUPAC system, that is your international unit of pure and applied chemistry. And in this, we are giving a name to the molecule according to the international standard, so we can facilitate the communication. If we are meeting the other scientist, if one scientist of one country is meeting to the another scientist of the another country, and they are naming a compound, then both should name the compound same, not the different. That in one country they are naming the compound according to their system, and the other country are naming their compound to their another system. So here a system, that is your IUPAC system, is developed so that both of the scientists of the chemistry can name that compound similar. So that is one, and they can facilitate the communication through that. So here, that the purpose of this IUPAC system of nomenclature is to establish the purpose of this IUPAC system is to establish that they are establishing an international standard of naming compound so that they can facilitate the communication. The goal of the system is to give each structure a unique and unambiguous name, and to correlate each name with a unique and unambiguous structure. So the goal of the system to give each structure. So here the goal of the system is to give each structure a unique and unambiguous name, so that they can correlate name with a unique and unambiguous structure. The next is a fundamental principle. So the IUPAC nomenclature that is based on naming a molecule longest chain of carbon connected by a single bond, whether in a continuous chain or in a ring. All deviations, either multiple bonds or atoms other than carbon and hydrogen, are indicated by prefixes or suffixes according to a specific set of priority. So here, the first is your fundamental principle. In this, the IUPAC system, IUPAC nomenclature is based, the IUPAC nomenclature is based on a is based on naming a molecule longest chain of carbon that is connected by a single bond. Means this IUPAC nomenclature is based on a molecule that is having a straight chain, means they are having a longest chain of compound and that is connected by a single bond, and that is connected by a single bond, whether by a continuous chain. So that longest chain of carbons, they are connected by a uh, single bond. So whether they are in a continuous chain, means if they are in continuous chain, then they will name that it according to that. If they are in a ring system, means in a ring, then we will name it according to that. So all deviations, either multiple bond or atoms other than carbon and hydrogen are indicated by prefixes and suffixes according to a specific set of values. Means here, if any in this longest chain, if there is any deviation, any changes, means if there is a single bond, then we will not name that single bond. If there is an double bond, if there is a multiple bond, means double or triple, or any other function group is attached to that longest chain, except this carbon and hydrogen, if any other molecule is attached to this chain, then we will indicate it, we will write it according to that. Means we will use the prefixes or suffixes according to the specific set of priority. Means that priority sequence table. According to the priority sequence table, we will apply the prefixes and suffixes according to that set of priority. So in this, the fundamental principle says that in this IUPAC nomenclature is based on naming a molecule longest chain of carbon connected by a single bond, whether it is in a continuous chain or in a ring. All deviations, means all changes, either that is your multiple bond or atoms or another atom that is attached to that, other than the carbon and hydrogen, are indicated. So we will indicate if any other multiple bond is attached or any other atom is attached, then we will indicate by the prefixes and the suffixes according to the priority sequence. Means according to the priority, we are just indicated by the prefixes and the suffixes. By writing its name, we will apply the prefixes and the suffixes according to their priority, means their priority table we have already discussed in the last lecture. So in that priority, according to that priority, we are writing or we are indicating the prefixes or the suffixes. Next is the alkane and cyclone. So the first members. The alkanes are the family of saturated hydrocarbons, that is, molecule containing carbon and hydrogen connected by a single bond only. So alkanes are the saturated hydrocarbons. Why these are saturated hydrocarbons? Because they are containing a single bond between the carbon bond. Because these alkanes are the family of saturated hydrocarbons, because in this molecule contain carbon and hydrogen, they are connected by the single bond. Like in the methane, you can say this is your alkane, because in that the carbon and hydrogen are connected by a single bond. Next is your ethane. So in that, this is also a alkane, because in this the carbon and the carbon hydrogen both are in connected by a single bond. So that is why they are alkane and they are known as a saturated uh, hydrocarbons. So the name of alkane. So these molecules can be in continuous chain, that is called your linear or acyclic, or in rings, that is called your cyclic or acyclic. The molecules can be in a continuous chain called linear or acyclic, or in a ring that is called cyclic or acyclic. These the molecules that are present or they are formed in a continuous chain, they are called your linear. They are called linear or acyclic. They are called linear or acyclic. And if they are present in a ring, then they are called your cyclic or alicyclic. Cyclic or alicyclic. So the name of alkenes and cycloalkanes are the root name of organic compounds. So the name of alkenes and cycloalkanes are the root name of organic compound, and beginning with the 5 carbon alkene, the number of carbons in the chain is indicated by the Greek or Latin prefixes. So here the name of the alkene and cycloalkanes are the root name. That if we are naming any molecule uh, in alkane, so these are the root words, alkane and the cycloalkane. Any organic compound means if any organic compound, these alkane and cycloalkane are the root name. This we will discuss in the examples. So the beginning with the 5 carbon alkane, the the number of carbon in the chain is indicated by the Greek or Latin prefixes. So beginning with the 5 carbon, meaning the starting 5 carbons of these alkane, they are um, they are indicated by the Greek or the Latin prefixes. This much is a Greek or Latin prefixes. Name of the alkane and cycloalkanes are the root names of the organic compounds, beginning with the 5 carbon alkane, the number of carbon in the chain is indicated by the Greek or the Latin prefix. So in this, the first 5 member of this alkane, that is your methane, S, prop, but, pant, these are the Greek or Latin prefixes, and the rings are defined by the prefixes cyclo. So if there is a ring, then we will firstly write the prefix, that is a cyclo, and the geometrical symbol for ring. Each apex represents a carbon with the number of hydrogen required to fill its valency. Means here, if it is given, if a ring is given and there is no carbon is shown in that ring, then the edges, the apex of that rings denotes the or represents your carbon, and the lines that are showing the bonds, and the carbons, it is shown, the apex are shown, each apex is showing the carbon, and the carbons with the number of and the carbon with the number of hydrogens required to fill its valency. If the carbon needs the 2 hydrogen, then we will, we will know that this carbon should have the 2 hydrogen with it, because it requires that carbons requires that 2 hydrogens to fill its valency, because it is attached or bonded to the 2 carbon atom. So total is your 4 valency. So in this, the introduction, the purpose of the IUPAC system of nomenclature is to establish an international standard of naming compound to facilitate communication, and the goal of the system, the goal of this IUPAC nomenclature system is to give structure, each structure a unique and unambiguous name, and to correlate each name with the unique and unambiguous structure and the fundamental principle. So the IUPAC nomenclature is based on naming a molecule longest chain of carbon connected by the single bond. So it is based, this IUPAC nomenclature is based on the system that is giving a name to a molecule that is containing longest chain of carbon which is connected by the single bond. Wherein whether it is in a continuous chain or it is a ring, it is represented in a continuous chain or it is represented in a ring. And all deviations, either multiple bonds or atoms other than carbons and hydrogen, these are indicated by the prefixes, means the other than the carbon and hydrogen, these multiple bonds, these function groups, these substituents, these are indicated by the prefixes and suffixes that are attached to that carbon and the hydrogen that attached to that carbon, and according to the specific set of the priority, means according to the priority sequence table. So next is the alkane and cycloalkane. So the alkanes are the family of saturated hydrocarbons. These are called the family of the saturated hydrocarbons because they are containing the single bond between the carbon-carbon and the carbon-hydrogen. So these alkanes are the family of saturated hydrocarbons, that is molecules. They are containing carbon and hydrogen. They are connected by the single bond only because in this the carbon hydrogen as well as the carbon hydrogen and the carbon carbon, these are connected by the your single bond. So these molecules can be in continuous chain. So these molecules can be in continuous chain, that is called your linear or acyclic, or they are represented in a ring, that is called your cyclic or acyclic. So these molecules, they can be in alkane and the cycloalkane. These molecules can be in a continuous chain. If they are in a case of your alkane, then they are known as your linear or acyclic, means they are not in a cycle. That is why they are called acyclic, and they are in a continuous chain. So, and if they are present in a ring, then if they are present in a ring, then they are if they are present in a ring, then they are called cyclic or acyclic because they are presented in a ring structure. And the name of alkene and cycloalkenes are the group name of organic compound. These names are the alkene and the cycloalkenes. These are the group names. These are the group name of the organic compounds. And beginning with the 5 carbon alkenes, the number of carbons in the chain is indicated by the Greek or the Latin prefixes. So in this, the beginning means the starting of this alkane, means the starting 5 member of this carbon of this alkane. These are the these are the the carbons that are indicated in the chain. These carbons that are present in the chain, they are indicated by the Greek or the Latin words. So if you are taking the first number of this alkane, then this starting from the first, then the CH4, this is methane. So the meth is comes from the Latin or the Greek word. Then the second is your ethane. So the ethane, it comes from this Greek or the Latin prefixes. Then the third is your prop, propane. So it comes from this Greek and the Latin prefixes. And the or fourth is your butane. So if this but comes from this Latin or the Greek prefixes. And the last is your pentane. So in this, the pant comes from the Greek and the Latin prefixes. So beginning with the first carbon alkene, the number of the carbon in the chain is indicated by the Greek or the Latin prefixes, and the rings are designated by the prefixes cyclo, and these are indicated by the uh, um, these are indicated by the prefixes, that is your cyclo, and in the geometrical symbol for ring. So the geometrical symbol for ring, each means here if the rings are if the carbon compounds are present in a ring, then we will use the prefix cyclo before this alkane. So this becomes cycloalkane. And in this, if they are present in a ring, then in a geometrical symbol of ring, each apex means each apex of the ring is denoting the carbon, and and that carbon with the number of hydrogen that is required to fill its valence, means to fill its valency. Okay, so this we will discuss in the examples. Next is your next like this. This is your alkanes and the cycloalkanes. So in this, you can see here, this is your CH4. So this is your methane. So this meth is your, this meth comes from the Greek or the Latin prefixes. So here we are using it meth. Next is your CH3, CH3. So this is your ethane. So this methane, ethane, propane, butane, and pentane. These words, these prefixes, this meth, it, prop, but, pent. These prefixes comes from the Latin and the Latin or the Greek prefixes. And if it's containing the one carbon, then we will use this meth. If it is containing the two carbon, then we will use this if. If it is containing the three carbon, then we are using prop. If it is containing a five carbon chain, four carbon chain, then we are using but. And if it is containing the five, then pent, six, then hag, then seven, then half, and this eight, then this is your octane. And if it is containing the nine, then it is your non. And if it is containing the 10, then it is that. So up to 10, this is your myth, 8 problem, 10 has half of non and the deck. So for the 11, we are using here undecan. So here, before this 10th decane, we are using this undecane. So next is your 12. So the 12 carbon, they are containing the 12 carbon. So they are using the word that is your dodecane. So dodecane is your 12, they are containing the 12 carbon in a continuous long chain. And then is your 13, that is your tridecane. Then it is your 14, that is your tetradecane. Then 15, that is your icosane. Then 16, that is your henicosane. Then your 7th, this is your 22, that is your dodocane. So here, this is your 13. This is your 13, 14. That is your tetradecane, and this is your 9, 18, 19, 20. So 20 for 20 here we are using this decane, and here for 20 for 10 we are using here decane, and for 20 we are using here icosane. Then this is your 21. That is your henicosane. So now 22 docosane, 23 tricosane. Then this is your 30. So here 30, for 30 we are using here triacontain. And for this 31 we are using hand triacontain. And for this 40 we are using here tetracontain. And for this 15 we are using here pentacontain. So these up to the 50 we are naming like this are continuous alkane chain or the continuous long chain. And now that this is your cyclopropane. So here you can see that before this alkane we are using the prefix that is your cyclo in case of your ring structure, and this is equivalent to this structure which is shown with the carbon atom. So here the apex of this carbon, apex of this ring, it is containing this carbon, and this carbon, as you can see, there are three apex in this cyclopropane. So it is generally shown by the three carbon atom. So these are the three carbon atom, 1, 2, 3, and one carbon is connected to the two hydrogen. So one carbon is attached to the two hydrogen. So here this this carbon is having the two hydrogen. It is having the two hydrogen with it. This carbon is having the two hydrogen. This carbon is having the two hydrogen. This carbon is having the two hydrogen. So it is having the three apex. 1, 2, 3. Three apex it is having, and this apex is denoted by this carbon, and the hydrogen that are present in with this carbon, they are filling the carbon valency. Means here this carbon is attached to this carbon atom, and we know that the carbon is having the covalency. So here the carbon is having the is here this carbon is attached to this two carbon atom, and here with this two hydrogen atom. So equals to 4. So here this carbon is attached to two hydrogen atom. And here also same, because in this also the same if this carbon is attached to the two carbon atom, and here similarly this third carbon atom, it is also attached to this two carbon atom. So it is denoted by this. Similarly in this butane also this similarly here are four carbon atoms are present. In this cyclopropane there are five carbon atom because it is containing the five affixes. So here the cyclohexane, in this also the six carbon atom are there. It is also containing the six six um, six carbon atom in it. And next is the cyclohexane. So in this cyclohexane there are seven carbon atoms that are attached to this. So here there are also seven carbon atoms attached to it. This cyclopropane. In this the cyclopropane, the eight carbon atoms are present. 1, 2, 3, 4, 5, 6, 7, 8. So there are eight carbon atoms are present in it. So this is the alkane and the cycloalkane. How they are represented? So in the alkanes they are represented in chain. So up to the 50 we have discussed, and what their names would be. And in the cyclo, how the carbons are attached in a ring. Next is the nomenclature of molecules that are containing substituent and function group. So here the nomenclature of molecules, they are containing substituent and function group. So A is the priority of substituents and function group. So in this listed here from highest to lowest priority, except that the substituent within group C have equivalent priority. Means here we are discussing the priority, and also we are discussing the prefixes or suffixes. So here the first group A is showing the function group that are indicated by prefixes or the suffixes. That what will be their prefixes and what will be their suffixes if we apply that function group in any chain, and also which is the highest and which is the lowest. So first is your carboxylic acid. So carboxylic acid structure is your RCOOH. So R here is your alkyl group. So R, wherever R is used, there it means that it is your functional group. Sorry, this alkyl group is attached to that functional group. So here the function prefixes that is used in case of your carboxylic acid, that is your carboxy. In suffix, the suffix that is used in case of your carboxylic acid, that is your oic acid, or you can apply the carboxylic acid. If three carboxylic acid groups are attached to any this three alkyl groups, then it means we will use their tricarboxylic acid. And aldehyde, in case of aldehyde, this is the second. So RCHO, and this is in this the prefix is represented by your formyl, and the suffix is your al. So that is your formaldehyde. Next is your ketone. So ketone is represented by this RCOR, and in this the prefix is your oxo, and the suffix is your on. And in the alcohol, it is your ROH, and in this the prefix is your hydroxy, and the suffix is your ol. So hydroxy, and in some cases we have to apply the prefixes. So we are using here hydroxy, and in the case of if it is having the highest priority in your chain, then we will apply it as a ol. Next is your amine. So in case of amine, that is your RNH2. So here we are using this prefix that is your amino, and the suffix is your oic acid or the carboxylic amine. So here the suffix will be your amine, and if we are using the prefixes, then it will be your amino in case of amine. The next is your function group that are indicated by your suffix only. So here the family of compound that is your structures, prefixes and suffixes. In case of alkene, so in case of alkene, we are using here C double bond C. If there is a structure like this, then there we will apply the suffix that is your in, and in this case there will be no there would be no prefixes, and the structure would be like this, that is a C double bond C. If there is this double bond in any structure, then we will apply the prefix, that is your ene. And in case of alkyne, we are using the triple bond. So here, if this is triple bond is applied in any structure, then we will apply the suffix, that is your ine. Then the group C, that is the substituents that are indicated by the prefix only. So in this, the substituents that are indicated by the prefix only, substituent structure, prefixes, and the suffixes. So in this case, substituent alkyl, the structure is your R and the prefixes is your alkyl. So if if R is attached to any of the group, then we will apply this alkyl. So alloxy. So here in case of alloxy, there is R plus O. Means here alkyl group plus the oxygen is present here. So here we are using this alloxy. From the alkyl we have taken this alk, and from the oxygen we have taken this ox. So it becomes your alloxy. So in case of your halogen, that halogens are represented by your X, and if any of this halogen, that is chlorine, bromine, iodine is present in any of the structure of the organic compound, then we will apply the prefix, that is your chloro, bromo, and ido. So here the prefixes will be your chloro, bromo, ido. Once again, that alkene, if in a chain there is any double bond is present in any organic compound, then we will apply the suffix, that is your or that is your ene. So we will apply the suffix, that is your ene. So here your like your ethene, means this is having the two carbon atom. So we will name it ethene, and the substituents are your hydrogen. So we will name it ethene because it is having a two carbon atom and there is a double bond between them. So its name is your ethene. Next, in case of your alkyne, its name is C triple bond C, then its name is your ethyne because it is having two carbon atom and one hydrogen atom. So in group C, the substituents indicated by a prefix only. So the substituent structure, prefix and suffixes, if the alkyl group is attached to uh, any of this alkyl group is attached, then it is the prefixes that is used with your alkyl. And in case of alloxine, there is the RO. R is the alk. So alk we have taken the word from the alkyl, and oxy we have taken from the oxygen because oxygen is attached to this alkyl group. The prefix is your oxy. And halogen, that is your FCl, that is your fluoro, bromo, and iodine. Next is the group C, that is your miscellaneous substituents, that is your NH2. So if any NH2 is applied with any compound, then there is we will use the nitro prefix. And if this double bond CH2 is applied, then we will use vinyl. If CH2 double bond CH2 is applied, we will use this allyl. And if this benzene type structure is attached, then we will apply it phenyl. Next is a common alkyl group. So in this, replace ane, ending of alkane with by ill. So alternate names for complex substituents are given in brackets. So here the CH3 is denoted by this methyl. This 3 is denoted by this isopropyl, or you can say 1-methyl ethyl. And in this CH3, CH2, CH, this is a secondary butyl, and you can write like this also, 1-methyl propyl. In case of this propyl, or you can write N-propyl. In this isobutyl or 2-methyl propyl. Next, this is your tertiary carbon. So it is because the tertiary carbon has the 3 alkyl group attached to it. So its name is your tertiary butyl or T-butyl you can write, or you can write 1,1-dimethyl ethyl. Next is your CH3, CH2, CH2, CH3. So in that case, we can use the word butyl. So in this, its name is N-butyl. This is your common alkyl group. Now naming substituent alkane and cyclohexane. Its group C substituents only are attached to it. So organic compounds, they are containing substituents from group C are now named following followed these sequences of steps as indicated on the example below. So step first, find the longest continuous carbon chain. So in this first we have to find that which is the longest continuous carbon chain. Next we have to determine the group name for this parent chain. And next, in cyclic compound, the ring is usually considered the parent chain unless it is attached to a longer chain of carbon, indicating a ring with the prefix cyclo. So here we have to use the word cyclo, prefix cyclo, before the root name. And when there are two largest longest chain of equal length, use the chain with the greatest number of substituents. So if there are those longest chain of equal length, means if there is a longest chain of equal length, and we have to choose that which chain we have to choose. Then we have to choose that chain that is having the greater number of the substituent attached to that chain. Next is your step 2. In the step 2, number the chain in the direction such that the position number of the first substituent is a smaller number. If the first substituent from either and have the same number so that the second substituent has a smaller number. So step 3, determine the name and position of each substituent and a substituent on a nitrogen. If any substituent is attached to the nitrogen, then we have to designate it with the N, like a N methyl, N alkyl, like this. Now step 4, then indicate the number of identical group by the prefixes by the di, tri, tetra. Means if there are identical groups are attached or bonded to the carbon atom, then we have to name or we have to indicate it by the number. Means if there are 2, then we have to indicate it by the di. If there are 3, then we have to indicate it by the tri. So in the step 5, place the position number and name of the substituent group in alphabetical order before the group name. In alphabetizing, ignore differences like sec, ter, di, tri, etc. but include iso and cyclo. So place the position number and name of the substituent group. In alphabetical, we have to write the name in alphabetical order and always include a position number for each substituent regardless of reductancy. Means here we have to indicate the substituent that are attached to that carbon atom with the position number. That if it is attached to the second position, then we will use the 2. If it is attached to the third, then we have to write the 3. Next, these are the examples. Like in this, you have to check that which is the longest chain. So firstly, we are checking that which is the longest chain in it. So here we have counted 1, 2, 3, 4, 5, 6, 7, and it is having the 7 carbon. And here 1, 2, 3, 4, 5, 6, 7, 8. So it is having the 8 carbon atoms in it. So here in this, it is having this 3 bromo, because in the third position it is bromo, 2 fluoro, and on the 5th position it is your propyl. So here 5th is your, sorry, on the 5th position it is your ethyl. So 5 ethyl, 4, because in the 4th position there are 2 dimethyl. Methyl groups are attached. So here we are indicated with the 2 because here 2 identical groups are attached. So here 4 dimethyl octane, because this chain is having the 8 carbon atom. So its name is your octane. So its name is 3 bromo, 2 fluoro, 5 ethyl, 4 dimethyl octane. Next is your 3 fluoro, because here you can see it is also the 6. It is having a 6 member ring as well as the 7. So 7 is the longest chain. So we will pick the 7 member longest chain. Then on the second position there is the methyl. Then on the third position there is the fluoro, and on the fourth position there is the isopropyl. So according to the alphabetic order, we are naming it, because F comes to first, then the I. So we are using the 3 fluoro, 4 isopropyl. Then M comes late. So here 2 methyl heptane. Next is your this cyclo compound. So in this, this one is having the longest attached is the alkyl group is attached to it. So its name is 1 cyclopropane, 3 cyclohexane, and numbering determined by the alphabetical order of substituents. Next is your alkenes or olefins. So alkenes are also known as your olefins. So these are characterized by the presence of a double bond between two carbon atoms, and third they contain two hydrogen atoms less than the corresponding alkane. So these alkanes are contained in the two carbon atoms, two hydrogen atoms that are less than the alkane. So these alkenes are having these alkenes are having the less hydrogen atom. Two hydrogen atoms are less than this alkene. So these are having the double bond in them, and they are containing attached by the double bond between the carbon carbon, and they are containing the two hydrogen which are less in this alkene than your alkane. So they are represented by the general formula, that is your CnH2n. In case of alkene, they are represented by the general formula, that is your CnH2n plus 2. And according to IUPAC system, olefins are derived from the corresponding alkanes by replacing the suffixes that is your ane by ene. Thus, olefins are called alkenes. So, olefins are called your alkenes, and they are also the unsaturated hydrocarbons because they are containing the double bond with them. So, they are also called olefins, and these alkenes, in this the suffix ane is converted to the ene. So, here ane is converted to the ene. So, here the first example is your CH2 double bond CH2. So, here this is the first member of the zero, and in this the ethene, because here two carbon atoms are present, and in this the suffix we use is here the ene. So here its name is ethene. Next is your CH3 CH double bond CH2. So in this it is having the three carbon atom, and there is a double bond is present in between the two carbon atom. So its name is your propene. So its name is propene. So here CH2 CH single bond CH2 CH3. So here this its name is your butenes, because on the first butene, because here four carbon atoms are present, and on the first carbon, first and the two carbon are sharing the double bond between them. So its name is butene. Next is your CH3 CH double bond CH CH3. So in this case its name is 2-butene, because on the second carbon atom it is having the double bond between the between the second and the third carbon atom. So that is why we are naming it 2-butene. Now next is your this is your 2-methyl 1-butene. It is on the second position with a methyl group is attached, and there is a double bond present between the first and the second carbon atom. So its name is your 2-methyl 1-butene. So its name is 2-methyl 1-butene. Next is if they are containing the group B suffix only, then alkene follow the same step for alkene include except the number the chain of carbon that includes the carbon carbon, so that the carbon double bond carbon has a lower position number since it has a higher priority than any substituent. And in this, change ane to ene and assign a position number to the first carbon of the C double bond C, and third designate symmetrical isomers with a fixed trans or E and Z prefixes. And in this 4,4 difluoro 3-methyl use 1-ene, and we are naming it from the right side. So 1, 1, 1, 1, 2, 3, 4. So here 4,4 difluoro 3-methyl use 1-ene, and in this 1, 1 difluoro 3-methyl use 1,3-diene. And the next is your, this is your cyclo compound, means cyclobutene. So here its name is your 5-methyl cyclopentane, because here two double bonds are present. That is why we are using 1,3-diene. And in special case, if cannot include the C sub double bond, then we will use this 3-vinyl cyclohexane, because it is a cyclo compound and this vinyl is a substituent. So we are using its 3-vinyl cyclohexane. So acetylene. So in according to the IUPAC system, acetylene are called the alkynes, and the name is derived from the corresponding alkene by replacing the ending suffix "ene" by the "ine". So here that's how it is. The "ene" is replaced by the "ine", and the position of the triple bond is indicated by the number. And in this also, the triple bonds are the unsaturated hydrocarbons. So in this, there are the triple bond is present in between them. So the alkynes are represented by the general formula, that is your CnH2n-2. And alkynes follow the same step as for alkenes to number the chain to carbon, that includes the C triple bond. So the function group has a lower position number. And in this, they are considered, the group B function groups are considered to have equal priority in the molecule with both a double bond and the triple bond, which is closer to the chain. So in this case, each would have the same position number and the double bond takes the lower number. In the name, ene comes before ine because of alphabetization. So here you can see this is a 4,4-difluoro 3-methyl with one ine, and if there is a presence of this triple and the second double bond, so triple bond is closer to the end of the chain. That is why we are numbering it from the left side. Its name is pen 3-ene 1-ine, and here we are naming it from the right side because the double bond is having a higher priority. So ene and ine have equal priority unless they have the same position number. Then ene takes a lower number. Next is a question, which of the following is an alkane, that is your B. And looking at the chemical formula of this compound, which is an alkane, that is your A. What is the name of the alkane which has the formula C4H10, that is your C, which among the following is not an example of alicyclic compound, that is your alicyclic compound, that is your acetic acid. Alkane is saturated hydrocarbon. What does this mean? It means that all carbon atoms are bonded by single covalent bond. Find the odd one among the following, that is your C branch chain compound. These are the references from where you can study this topic. And thank you so much for today's lecture.